So let's get started. So basically today's talk is going to be on React app bundling based on HTTP versions. I'm Santosh. I work for this company called Rubrik as a software engineer. And here are my social media links. And I basically work on UI infra, dashboarding, monitoring, and sometimes work on the projects also. And a little bit about my company. Yeah, next time my manager should give me some permission to attend the other conferences, right? So yeah, just kidding. So basically we work on some protection of cloud workloads, data center workloads, and so on. And we are under the mission of securing the world's data. And so we started as a data backup company and then moving towards cyber security and cyber resilience. And if you are a company or like individual who needs backup of your data center, cloud workloads, just try it out. It's cool. Yeah, let me set the context right. So basically, I'm here to talk about the bundling part, but it is nothing about like the bundlers that we use in React, like Webpack, Vite, or anything like that. So it's mostly about, I have a bundle, like I have multiple chunks of bundles, and how would I load it in the browser, in the client? Right? That is going to be the talk on. So like basically the timing is very important, right? It's not just the ingredients, like what is very fundamentals for us. Like basically the food, like let's take example of biryani, which most people like, maybe Meghna. What else? Any other suggestions? Cool, whatever. So basically like it's not just about the ingredients, right? It's about the timing, where you add the ingredients mostly. Like the same way, it's when you take the clients or the browsers, it's not just like you load all the resources aggressively. It's about at what time you load it or what time you bring it to your browser and how efficiently you are bringing it to the browser, how soon you are bringing it to the browser, and then get it executing, up and running, get the functional app for the user as soon as possible. That's about it, right? And that's where this priority comes into the picture. And the whole talk is going to be more about the HTTP priority, the resource priority. This is more fundamental, like unlike other talks, you can apply this with any of the applications, like a normal HTML, CSS, JavaScript application, React, Vue, any client-side application you can just think of. And then it's just like, because it is React Nexus, I have named it as React App Bundling. So let's get started. So basically, the browser is a very simple software, right? And it has a very cute or simple parse rules, right? So the parse rule is very simple. Like I will just take one at a time, one token at a time, parse it. So CSS, HTML, JavaScript, whatever it may be. I just go synchronously, take one token at the time, parse it, right? So if you take CSS, it is render blocking. Obviously the HTML is render blocking. And when you parse the JavaScript, which are synchronously loaded, and it is also render blocking. And it waits for the JavaScript to download also. So that is also blocking the render. So basically how you load bundles or whatever the resources that you want in the browser totally depends on your HTML structure, right? How you write your HTML. Whether we clean the shit up or whether we rewrite it in some other way or we will remove the shit completely. Like shit meaning the resources. Like if you have a resource, if you want it to speed up, like if you want the performance to be better, just reduce the number of resources that you load or change the way that you load, right? These are the two things that you do. So how would I change the way that I load? I would say you can just offload few of your resources by deferring when it is loading, right? So one is like fonts, which basically the browser even does it. Like fonts, it defers the load, and background images, it loads separately, like later after all the other resources are done. And script injected content, like say you run a script and from there is some content which is getting loaded. and that is also is going to be deferred, and all the other imported stuff from CSS and ESX bundles, right? Let's consider a simple analogy where like a sample React bundle, like HTML, CSS, main JS bundle, and a vendor bundle, and like do some asynchronous scripts, maybe for a pop-up, or maybe something like to get some monitoring data, or to do something else, right? Like say maybe you can just do something like pendo to the user, which can be loaded asynchronously, need not be loaded synchronous and block the render, right? And there is this font thing, which I hate the most. I will tell you, like I have a whole story about it. And yeah, there are kind of 15 images in the sample sites. Just take this analogy. And then like, yeah, so what we do usually, like basically the thing which I am showing here is a bit opinionated. But yeah, so basically when you want to load resources faster, you try to parallelize the download, right? But the problem with parallelizing is we often forget about the bandwidth that the user has, right? End of the day, it's all about the network connectivity that the user is going to have. If he's going to have a bad internet, he's definitely not going to get the better page load time or performance, right? So let's consider in a 3G environment, like if the user loads the site, if the bandwidth is like limited, and he tries to parallel, like if you are trying to load the resources parallelly, then his performance is going to be affected basically because in parallel world, the execution will be synchronous again, the parsing and the execution. But if you load it synchronously, like first download the script one, so it gets the entire bandwidth, so it gets downloaded very easily, or like before whatever the expected time is, and then start executing it. In the meanwhile, start downloading the second one, right? So we often tend to miss this bandwidth thing, and let's take this one. So it is, I don't know whether it is clear or not. So basically, it's like a simple ideal case, like if you load your web page, like the analogy which we took, if you load it in this way, it will be really cool. Like you have HTML blocking, CSS blocking scripts, load it one by one, download it, and then parse it, execute it, and then the fonts, and then the images, which are in the viewport. So here I'm not loading all the images, which are going to be in the viewport, which I know is going to be viewport initially. I just take those 5 images and then load it. And then I go for asynchronous scripts, and then these images, right? So these images are very important. So basically what people tend to do is load it lazily. But the problem with lazy loading is the user experience drops. That is a race condition. Like I scroll down, and then I see some images loading, but before that gets loaded, I get to scroll again, right? So this is going to be a race condition, which is like not going to be a very good user experience. Instead, preloaded. That would be my suggestion. And right, so we are one of these people like who came across this 3 HTTP version upgrades, right? Initially it was 1, 2, and 3. Like maybe it's like I started coding by 2014 or 2015, and then it's like 3 versions we have come across, and no people like who have been in the industry for 20, 30 years before have not come across these many HTTP version upgrades within the short duration. And in this version, like HTTP 1, you have 6 connections per origin. And then like there is this browser which maintains the linear list of resources, like which needs to be downloaded. And then we go like pick each one of them and then download it. And this 6 connection is like very specific to Chrome. And then it depends on the number of like different types of browser. Let me just quickly run through. Yeah, so this is about HTTP 2 prioritization. Here the prioritization is bit flexible. Like here, the browser has very less hold. It can tell that, see, this is what is going to be required for me on priority. But the server is the one which is going to judge what I need to send first, right? So if your server is not good, you are not going to get better benefits out of this HTTP 2, right? So what I mean by the server is good, so when I send the priority, it should respect the priority back, right? Say if it is going to take more time for loading the priority stuff, then obviously the web performance is going to be affected. And like why this is different from HTTP 1 is, here it is going to be one particular connection per origin, right? Say for example, in case of the HTTP 1 world, we are going to have 6 different connections, like a usual TLS connection or TCP connection for each, and like for the same server, we will have 6 TCP connections open. But in case of HTTP 2, we will have only 1 connection, but it is multiplexed. That's mostly it. And here, what else did I miss? Yeah, the priority varies from 0 to 255, and then that is like for the particular browser-based thing. And this is about the cross-connection complexity. So basically, people do tend to mistake this one, right? Say upgrade from HTTP 1 to 2, but they will feel that like done, like the work is done. But if you see the performance, it is not improved. Rather, it would be decreased because you would still go with this domain sharding and things like that, right? So basically, the HTTP 1 kind of people, like the old people in the crowd. So basically, the domain sharding, the problem is like for in case of HTTP 2, the problem is like you will not have the context. The priority will be specific to a particular origin, particular server. But when you have multiple servers and you will not be able to have one single priority thing, and because of which you will get the problems. And you can do something with this connection coalition and things like that, but it wouldn't scale up very well. If you are using something like CDN or something, it would be a problem. And web fonts, this is like a love-hate story. I would just quickly complete it, like maybe in a minute. So basically, like when what happens, like with that too, we'll take a specific analogy of this Google fonts, right? What happens is first you add the CSS at the top of your HTML, it gets downloaded, and then it will get like a separate origin or a separate server from which it will download the actual fonts. So it is like two different connection, two different 3GP connection, two different DNS lookup, socket connections, and like everything is different, and it adds a lot of latency, right? So I don't know how to fix this, but yeah, this is a problem that we go through each and every day. Proxying the fonts would be one easier or maybe something similar of a solution, but didn't work so well. But preloading the fonts has actually worked well for me. Try it out, and CDN servers, just try it out. Akamai, Cloudflare, Fastly, these are cool. H2O and Apache are the two web servers which are cool. But Nginx is like having some issues. You can just check out this ticket. I'll just post this like presentation in my social media accounts. Just check it out. And HTTP 3 May, how would this come to conclusion without talking about HTTP 3, which is hot cake now, right? So basically, we moved towards a UDP-based connection and increased application layer responsibility, moving the TCP connection and everything, like the congestion control and everything there, right? So, like, means when you use CDNs or Nginx, Apache, you would not only just take care of the prioritization stuff, but also the congestion control and buffering and all these things. And obviously, the one cool advantage of using this HTTP 3 is you will not have any man-in-the-middle attack. Like, and obviously, the enterprises will not steal your data. Like, you work for your company, and then obviously, they are going to track whatever you are going to surf in your laptop. Right? With HTTP 3, that would not be possible because this is all happening in the application or the network layer, and most of the loads are taken offload. And like usually, the only way for the enterprises to get your data is to just block all the UDP requests in 443, and then just support the fallback of HTTP 2. And HTTP prioritization just have this two values. One is this urgency and increment, whether it is incremental or not. It is a HTTP header. When it is you don't have control of anything else. Browser will take care of this, but it is very simple. Instead of having 0 to 255, which is there in HTTP 2, it has just 0 to 7. And incremental means whether it can be streamed or not, whether you can get the chunk of the stream and then complete your work. And the key takeaway for this talk is just like ask why. Why is it happening? What is it happening? Just get into the details. Don't try to fix this latency related stuff just like that, right? Like say that is what the infra guys usually pretend to do. The problem is that. So just try, get into the details. You will get the actual fix instead of doing some hack around it. Thank you so much. Like this is what else I can expect. Awesome crowd. Thank you so much. Yeah. Write accessible code, code with empathy. Thank you.